Hi, this is Jake Simard from the class of 2012, and I'm going to be doing problem number 18 on page 219. The problem states that a wheel 33 centimeters in diameter accelerates uniformly from 240 RPM to 360 RPM in 6.5 seconds. How far will a point on the edge of the wheel have traveled in this time? Alright, so after reading the problem, we have realized that the diameter of the wheel is 33 centimeters, or 0.33 meters, and the radius, since you just divide that by 2, is 0.165 meters. The initial velocity is 240 RPM, indicated by omega O. The final velocity is 360 RPM, indicated by omega F. And the time is 6.5 seconds. So, what do we have left? They want us to find how far will a point on the edge of the wheel have traveled in this time. So we need to find what is obviously the distance of that point, what it has traveled, which is indicated by delta theta. Our problem, however, is that considering the variables that we have now, we're not going to be able to get delta theta right away. So what we need to do, we need to use another equation. This equation being final velocity equals original velocity plus alpha t, which stands for acceleration times time. Now, the thing is that right now we have it, the initial velocity and the final velocity in RPM. And since we have seconds, that's not going to do. So what we need to do, we need to do a little bit of converting. So we need to do a little bit of converting here. So we start off 240 rotations per minute. 1 rotation equals 2 pi radians, and then 1 minute equals 60 seconds. Once you do all that out, multiply and divide where you need be. For the initial velocity, you get 25.1 radians per second. Now, all you need to do is just do the exact same thing for the final velocity, but replace 240 rotations per minute with 360. Once you do all that, and you do a little plugging and chugging, you get 37.7 radians per second. Now, instead of being in RPM, since these are in radians per second, it makes it a lot more compatible with our time equaling 6.5 seconds, instead of some odd number of minutes. Alright, now that we have all that fun stuff in radians per second as opposed to RPM, we go back to the previous equation. Notice how earlier I isolated variable alpha, so now we have final velocity minus original velocity divided by t. So now what we do, we just plug those in for the final velocity, 37.7 radians per second, minus the initial velocity, 25.1 radians per second, all divided by 6.5 seconds. So once you do that little plugging and chugging with your calculator, you get to the answer that is the acceleration is equal to 1.94 radians per second squared. Alright, so now that we have the value for alpha, now we can use that to our advantage in another equation. We'll use that to determine delta theta. So what we'll use it in is velocity final squared equals velocity initial squared plus 2a delta theta. So what we do, we just isolate delta theta. So you get final velocity squared minus initial velocity squared, all divided by 2 alpha, and that equals delta theta, obviously. So what you do again, routine, just plug and chug. Final velocity, 37.7, don't forget to square it, minus your initial velocity, 25.1, don't forget to square it, all over 2 times 1.94. Then, once again, after plugging and chugging, you get delta theta equals 203 radians. However, there's one minor setback. We're not done yet. Even though we have delta theta as 203 radians, that still really doesn't tell us the distance that a point on the actual wheel traveled during this 6.5 second period. So what we need to do, we need to convert this from radians into actual meters, an actual measurable distance. So what it is, just keep these in mind, that 2 pi radians equals 1 revolution, and 1 revolution equals the circumference of a circle, and the circumference of a circle equals 2 pi r. So what do? Conversions all over again. Yay, fun. Okay, so you have 203 radians, and then put it underneath 2 pi radians equals 1 revolution, since that was stated above, and then 1 revolution equals 2 pi r meters, and since r is 0.165, which we did got earlier, just plug that in, multiply, divide where it's need be, and then the distance traveled equals 33.5 meters. Now obviously, since our seconds that was portrayed is 6.5 seconds, and that only has 2 sig figs, you need to change that from 33.5 and round up to 34 meters. And that's the end of the problem. I hope this was of help to you, and if I made any mistakes, I am deeply sorry, and I hope Mr. Kaplo helped you out with them. Thank you for your time.